So please welcome on stage Nicolai Josuttis with a great keynote.
Thank you. Thank you very much. Thank you very much. Let's see. How many people in this room think they have roughly understood C++? Okay, let me rephrase. How many think that they have understood more than 50% of C++? 3. Okay, I didn't raise my hand. When I prepared this talk, I don't tell you what I dreamed the night before. It's just that I thought this might be an interesting title because I heard some people have stolen this scheme to write an interesting book. And the question that came up yesterday is, when we had some wine here, Nico, are you sure these geeks have any clue what you're talking about? So just to make clear what I'm talking about, the left thing is a tie. And the middle thing is a mask. And about the right thing, we will talk in the next 90 minutes. You're prepared? Okay. Torture. Here's the first torture. Assume I want to write a simple program. A very simple program. Maybe a beginner, a first lesson about what you can do with C++. So what you might come up with to say, oh, there's a simple class called customer. Customer attribute is a name. The name must not be empty. Maybe you can raise down a little bit the mic because I have a slight feedback. Thank you. Let's create a constructor, a setter, a getter, and an output operator. And it might look like this. Who here in the room would write this code like this? Nobody? Nope. This is a shy group. Oh, you know better. So, I would teach this that way. Well, we might discuss about whether we should use assert here, or exceptions, or whatsoever, or bring the customer into an interesting state when the name is empty. But it turns out that we can improve these slides, this class, a little bit. So, first of all, the output is Nicolai. So let's first talk about the first problem, initialization. This is a language that has some history. And some history was almost 50 years ago when C was designed. So we started to initialize objects or variables, not at all, or with the equal sign. Okay. So we then introduced C++, and because C++ like to pass multiple arguments to objects, we created a new way to initialize objects, which is using curly braces, using parentheses. And that we also extended to be useful for int. And then there was this area of uniform initialization, which we introduced in C++ 11. So we introduced a new way of initializations using curly braces. Now, I have an interesting problem. I give a couple of trainings, and recently, for some reason I don't understand, more trainings to beginners than to advanced programmers. So which one of these ways to initialize an object should I teach? And by the way, because it was fun, I thought, oh, well, let's look at some other ways why we introduced uniform initialization, because we could then skip the equal sign for initializing an array. We could now use curly braces for initializing objects, and we could even initialize vectors of strings. So that was the idea. But the outcome of this all is that we have a mess of ways to initialize objects. So just let's look, how many ways are there to initialize an int? So we have these 4 ways introduced before C++11. Then we introduced the curly braces, so we have another 4 versions, sometimes with the value, sometimes without. And then we have auto, of course, almost always auto, which has some interesting question marks here we have to talk about. And then I thought at this point, so maybe if we have 12 ways to initialize an int already, let's try out some weird other things. So what's this? Does this work? Oh, it's a function, yeah. Good. Does this work? Who thinks this works? You're wrong. Does this work? Who thinks this works? You're right. And the same is true with an equal sign and with auto. So again, what should I teach? Well, first of all, I would say, as this is a bit confusing what works here and what not, because sometimes this is in fact the comma operator used, sometimes not, don't use parentheses anymore to initialize an object. So then let's talk a little bit about initializing with auto. So we introduced this, and then we introduced the curly braces, and there was a mistake we made, because everybody would think that I10 is an int, but it isn't, or it wasn't. It was standardized to be an initializer list of ints. This was fixed, because it was so counterintuitive that even as we would break existing programs, and we did break existing programs, we fixed that. That doesn't happen very often in C++ standard. So unless you use an old compiler, you can think yourself about whether your compiler is old according to these versions. This works now, as expected. But standardization sometimes is making compromises. And there were these guys who said, well, in my template code, sometimes I have a couple of values and I want to initialize an initializer list. So I need some way for that. That's like in politics. Compromises are not always good, because this effectively means that an equal sign in the initialization might change the type of the thing we initialize. How counterintuitive is that? And that was the first time I felt torture. I thought, what a group is this? What is the value system of the people who standardize this programming language? You're laughing, that's not fun. Have you ever encountered that? Have you ever tried to explain this to beginners? There might be a solution, by the way, once we introduce something like initializer list with auto, or with class template argument deduction and having a good deduction guide. This might even work now. I didn't know about that, but when I last time talked about this topic, somebody came afterwards and said, maybe that's the way you should do it. And yeah, maybe we should do it that way. Good. So don't use an equal sign for initialization. Great. So, but the question is, should we use auto or not? There's this fraction, this group of people who heard about this term, almost always auto. Who is a fan of this term? Who think this is a good idea? You should be skeptical. It sounds too easy for C++. How could something be simple in C++? So we have a couple of interesting things, like here. It looks pretty good. When we have this initialization with an int. When we initialize a string, yes, we can do that. But you have to have a using declaration of namespace using namespace st-literals. Maybe it's time to introduce and make the S suffix globally available, not part of std. We discussed that. Recently, I asked that, isn't it time that we do that? And the answer was, we have no useful type what this expression should yield. We think if a string literal appendix with s yields an std string, that's in many cases too expensive. If it yields an std string view, that's in many cases too dangerous. So we have no type yet for a good working type representing string literals. And I just saw a proposal that we might come up with that later, and maybe finally after 20 years, coming with a useful type representing string literals. Sometimes we make our homework, yeah. Sometimes not. And then there was a problem why we had almost in these three acronyms. So almost always auto. The reason we had almost was because some things didn't work. It didn't work to initialize with this syntax, with auto and equal sign and atomic. The good news is it works now. Because we have modified the way, we have modified the rule that using an equal sign needs support of copy semantics or move semantics. And for a similar reason, now it also works effectively to initialize std arrays. So for some reason, we could say this now has a rule being always auto. Not just almost always auto, but there are a few things left. For example, if you declare long, this is unfortunately not correct syntax on the right side to have there long. So you might use a static cast or an ent64t, which is not the same. And we have interesting trouble with references. So if we initialize references that way, this does not what you expect, because the thing on the left, auto, decays. And if you initialize an auto, it can't be a reference. It will be a new object. So this is no longer a reference. So you need at least one reference sign here. When I gave this talk the last time, I thought, maybe we have this universal reference called autorefref. Maybe we should change the whole rule and say in all these cases, on the left side, we always write autorefref. That might solve the issue. And we change the whole rule as quadruple A. Always auto ampersand ampersand. The problem in this community is the more scary a proposal is, the more people like it. And even worse, they always find at least one useful application. I'm not kidding. After my talk, it was at CPPCon, I got a couple of tweets and messages asking me, why do you think always auto ampersand ampersand? So using always on the left, auto ampersand ampersand is a joke. I got these emails. Torture. So what I propose and what I teach now is, as a summary of this situation, no, don't use auto, almost auto, or almost always auto, or whatsoever. Don't use parentheses, don't use an equal sign. Just initialize by default. There are reasons for other cases. By default, without, with the braces, and without the equal sign. And the experiment I did is, I did C++ for more than 20 or 25 years now. I had to change my style. And it happened because we ran a big project with a new team of 200 programmers, and we decided that we teach this from the beginning. And the funny thing, after 3 months, I got used to it. I felt comfortable using braces for initialization. The funny thing was always this loop. This looked weird. If you have come over the point where you, instead of using an equal sign here, using brace initialization, you have done your next step for a better C++ life. So, of course, we should use brace initialization here. I skipped a couple of advantages of it, so there are more than the ones I just listed. And there were also some problems left which we fix in C++ 20. What else is wrong with this class? Move semantics. Should anybody who writes this simple class change this class because of move semantic? Should an ordinary application programmer ever implement std move? The interesting answer to this question is no, in theory, but yes, in reality. And the killing argument is always performance. Because what is the problem with this declaration? If we have this declaration, just the declaration which calls the constructor, we have a problem. We have a string literal, and this string literal first has to convert to an std string. Which, unless we have the short string optimization, allocates memory on the heap. So it might be pretty expensive. Just think about that. This is just not Nico, it's the Leuthäuser Schnarrenberger. This is only a joke for the Germans here in the room. Maybe you explain your neighbor. And the problem is that this creates somehow a temporary object, but this temporary object n has a name and is const. So when we then use it to initialize the name, we create another copy of this object. 2 allocations just to initialize this customer. Sounds not very reasonable and something we should improve, and we can. That way, we can just say, take the argument by value and move it into the member. How many program that way since C++ 11? That's less than the half. That's 20%, I would say. It's funny. C++ 11 is 6 years old. No, 7 years old. I can't count. And we still don't use it appropriately. Because this is not worse than the other way. In fact, call by value is easier to teach. But yes, I have to teach move. How do I explain to beginners what move does? When would you teach move to a beginner? In the first or in the second or in the third week? Full week? which means in the first, second, or third semester in a university. Roughly. Sorry. That's the way we should do it now and teach now. But the question is, when should we teach it? So now we create a temporary, and the allocated memory from the temporary gets stolen when we initialize the member. Pardon? The assort failed? Yes, you're right. Good point. Do we have a significant problem, or can we fix that? Yes, we have to fix that to name, and I think sooner or later in my slides I do it. But I only had the first slide and the last slide, and this is an intermediate slide, and I forgot to fix it there. I hope. Good. Should we do it somewhere else? Yes, of course. In the setup, we have the same problem. The setup also had the same issue. Because what we have here is a sync parameter. We pass something where we say, this is now your value. So it's better first to create the copy and move it into the new member or the existing member instead of taking it by reference, which at first is fine because we don't copy it, but later on, as this initialization of a reference might be expensive call, might result into two calls. So this should be the way you do it, unless your class has 20,000 members, which are all double. Because then it might be counterintuitive or counterproductive, excuse me. Okay, it's not that easy. But we are not done yet. Let's talk about the getter. What's the problem with this getter? It breaks in encapsulation. So we might say, yeah, of course, that's a common scheme. A common scheme we hear very, very, very often in this community, saying a getter of a member should return the access to the member by reference. And if it's non-const, that's a good way to change it. But of course, as we have some assertions regarding the name, we break encapsulation. So don't do that. But in general, returning a member by reference is fine. Is there a problem with this? Well, let's use this code. Let's have a function that returns a new customer. And this new customer, which is returned as a temporary object, as a PR value. And we take this expression, or this as part of an expression, and then iterate over the returned characters in a range-based for loop. So let's iterate over the characters of the returned new temporary customer of the name of the returned new customer. And the problem is we have undefined behavior. We have a runtime error, not a compile time error, because although references extend the lifetime of temporaries, they don't extend the lifetime of a reference to a temporary or the underlying temporary when you return a reference to it. And this is exactly what the range-based for loop does. The range-based for loop internally creates a reference to the thing on the right, which is a reference to a temporary, not the temporary itself, and that means it does not extend the lifetime of the temporary, and we start to iterate over the characters of something that was destroyed. There are style guides that say, beware of the range-based for loop. It's strange. This is such a nice invention, and we have to think about when to use it and have to use it carefully. Oh my goodness. There's a way out, by the way, which is almost nowhere used. It's like this. So don't fall into the problem of making this mistake. And the way you can do it now is to say, if I have a temporary object, if I have a PR value, and that's the first get name thing, I have overloaded it in a way that it returns the string by value, so that we can create a copy. And in all other cases, we don't want to break encapsulation. So we use, if we have a const L value reference, let's return it by a const string reference. Who is using this pattern in getters now? 3. That's available for 7 years now. This is something we introduced with C++ 11. Okay. So anything else I should do better? Yes. There is another subtle problem, which brings us to the topic of hidden friends. It's time to deal and to play games with the title of this talk. Who knows what a hidden friend is? Nobody. Are you serious? The funny thing is, I didn't know either. But 2 months ago, we met in Chicago to talk about C++ 20 in the library working group. And in this group, we talked about a bug report. Look at this code. This is a main function. The main function takes a long string, also a white string. A//b is a value. And an ordinary string, std string, taking an A/b, which I would assume are 2 different values. Do you agree with us? So an assertion comparing them, if it compiles, should fail. Why does it compile now? Because both convert to string view. And then somebody said, oh, we have a cool new library in C++. It's called the file system library. So let's include the file system library and their identifiers, and suddenly this assertion did no longer fail. What? What was the problem? Well, we had introduced in std file system a class called path. And the path constructors were not explicit. And we had a comparison operator. And the comparison operator took 2 paths. It was defined globally. So because of that, it would be used if both of these strings were able to be implicitly converted to a path. Which is because they have different types, they don't use their own comparison operator. So how do we solve that? With hidden friends. What is a hidden friend? Make this equal operator part of the class. Because the rule is, if you have an operation that is inside a class, it will not be used if not one of the arguments has your type. And that's surprisingly a rule we now introduce to say, make sure that we have no implicit type conversion which has a dramatical impact to just some arbitrary other types. Because the problem, of course, was on a file system path, it didn't matter how many slashes you had in the past. This is called a hidden friend. And of course, our class should also have this change. Why? Well, you never know about the side effects. It depends a little bit on your type. So I have created some other examples where I have an interesting type with some interesting type conversions. And again, the same, it might be that suddenly you can print out an object of a class and you get something totally different because you have an implicit type conversion to another type that introduces this output operator. But there's another good reason. If you call output operator for a type that doesn't support it, there are these features of the compilers that give you all the candidates that could use it if there would be some type conversion. So with this, your error message listing all the candidates that don't fit to this output operator is decreased by 1. So you only get a list of 30 possible candidates instead of 31, which in fact is this whole program with the header files gives you, if I try to, I think I tried out to output a pair of 2 customers, and then, yes, 1 error message less. So, let's talk about shades. We switched from the thing on the left to the thing on the right. 2 ways just to implement a very, very trivial class. Which one is right? Which one is the one you teach, including all combinations? That's tricky to use. It's probably a rookie style, and this might be the more experienced style, but still the lazy style, because an advanced programmer would overload all the possible implicit type conversions and because even a move is expensive, and say, okay, let's overload the constructors to have, I don't know, 20 overloads. Well, in tuple, we only have 30 overloads, so that's some fun for novices. And the setters might apply to the same rule. And again, my problem is, what should I teach? What should I teach to beginners? Should we agree on a common scheme? So let's talk about the 50 shades of C++. First of all, there is no single C++ style. There is no single truth about the C++ style. Second, there is no single way in teaching C++. It might depend on your audience. For example, the 200 people I currently teach are in an embedded area where they don't have heap memory. So we have pretty early to talk about arrays and pointers because they still use string literals as constructor. And at latest, when they want to deal with command line arguments, you have to explain something that is not an std string. How could this happen? What did we make wrong? Let's make clear where we are. We have a big software project, a software produced for 4.5 million programmers. This software project runs for 50 years now, including C, because we are backward compatible to C. And we are both backward compatible in API and in ABI. And there might be a 4th problem. This is community-driven. This is the way we work. So we have hundreds of people caring about it, who come together in the committee. We have different working groups caring for the language, caring for the library. We have special groups dealing for, I don't know, concurrency or whatsoever. And usually we meet now and have something like over 170 people coming together. This is community-driven software. There is no chief architect. We all care. So Andre, if you listen, it's your fault. that const if is not the way in the language you want to have it, because you haven't been there. Don't complain. It's your fault. Hey, we are not paid. I'm serious. We are not paid. There's nobody paying us to fly over to some moments, spend a lot of time going out frustrated because other people find it differently about what's useful for C++. And that's one thing I would like to say. The alternative is you pay us $10 million a year. Then we will make good design. What? These are the numbers of. This is part of our problem. We are victims of our own success. So in the past, when we standardized the first standard, I was even involved here. I'm that old. We were about 50 people coming together and talking. And we talked about, look at this. In a meeting, we talked about 20 papers. And now we have really an increase in people attending C++ standardization. Last time we were 180, 1 week ago. And what is really frightening, the number of papers has dramatically grown to be more than the number of attendees. There are people who propose 10 papers, and they feel good. And we have to discuss everything. Yes, we have a problem. We have a problem with the success we have. So don't complain. No, it's okay to complain. But please constructively come to our meetings and help us. This all leads to a problem which is known from psychology, which is called the Virginia-Satir change model. So because what this means, what we do in C++ all at the time, and each of the time, we standardize change. With each standard, we introduce something cool new, but something cool new is a nightmare for others. And there's a psychological way to see change, which is there's a foreign element that disturbs us, the old status quo. We're feeling comfortable, and something move semantic comes along. And we run into trouble. And I talked to Dan Sachs yesterday, and I asked him, what do you think, how long does it take between standardizing something and find the appropriate style to use it? And we agreed it's something between 5 and 10 years. So we need some transforming idea, which might be a fix in the language, which might be a good style guide or whatsoever, dealing with practice and integration, and then come to the new status quo. Practice and integration is still the term here of this model, but it fits perfectly to our community. Yes, and we don't have one change, we have a lot. Some with more impact than the others. So this is the heart of the problem of the 50 shades of C++. And it's getting darker. That's the second part of the book series. I thought a long time what example I give you here as a really frightening evolution of C++. And I decided to use value categories. Who's familiar with value categories? Okay, if I say it in other words, who has heard about the terms L value and R value? That's what we call value categories. So value categories were introduced in Kernighan Ritchie C in 1970-something. And it meant that when we write manuals about C there, we need some rules. Instead of writing on the left side of an equal sign can be an int and a float and a we say on the left side there can be an L value. And an int is an L value. So we have categorized different types. And L value stands for the thing that can be on the left side of an assignment. And 42 is an R value because it can't be on the left side because you can't assign something to 42. One of the weirdest experiences I did when I started was in some small talk flavors you could. But okay. It's not only about this. It's not only about the assignment operator. There are a couple of rules bound to these two terms. So for example, can you take an address of something? And the rule was you can take the address of an L value, but not of an R value. Okay? And then the first drama appeared, which was C got standardized. And we got ANSI C. And we introduced something called const int. So, no, can no longer be on the left side of an assignment, but you can take the address. So, how should we name it? And the decision was, this is still an L value, but the L stands now for something different. And it's a localizable value. And R value is roughly a read-only value. Good. So, so far so good. And then we adopted that in C++. And in C++11, we invented something called move semantics. We had that before. And we had the following problem. If you have an object marked with move, it's OK to assign something, but it's not OK to take the address. So is this an L value? Or what is it? And the decision was, this is an X value. Because this is an expiring value. And it was even worse. When we looked at it and saw, well, in many, many cases, an X value is like an R value. So let's make the following trick. Whenever we write R value, it now represents what was an R value before C++11 or an X value. And let's rename R value to PR value. Did you get that? It's easy. So this is the resulting diagram. We don't have many figures in the C++ standard, but the thing on the right is a part of C++, of the standard. So we now have three basic categories: L values, localizable L value, PR value, which was formerly called R value, and now X value, which is an expiring value. And here are the exact rules, what this is. No, the exact rules are 20 pages. But this is roughly the rules, and if you want to keep it in your mind, please just remember the following rule of thumb. An L value has a name or is a string literal. And PR value is a temporary or another literal. And an X value is a value for move. So now you have learned about what value categories are. And then we thought, this is a little bit too complicated. Well, let's keep them the same, but teaching it, and we had some inconsistencies, because there was this question, is this an object? Is this an object? So when is it an object, and when is it not? And we changed this again in C++17, and we made it, well, we didn't change the rule about what compiles and what not, but we changed the nomenclature, so the way we think about the paradigm, the mental model. And the mental model now says, we have roughly two things. Things that are objects and things that are no objects. Just some initial values. And the one thing is called GL value, and the other thing is called PR value. And the PR value is more or less, has only the task to perform some initialization, but you can pass it around. So the reason the auto-initialization with atomics now compiles is because on the right, you create a PR value, which is passed around to the things on the left. And you don't even need any copy or move as constructor at all until you really create an object, which is because you initialize an object or because you need a reference of it. And then we say the temporary materializes as an object. Who has heard about that? A few. Oh, they were all in the standard committee. No. Good. So, forget it. Compilers know that. The only interesting thing is what this means. And what this means is, if we declare an object to be an R value reference, it takes only, as the name supplies, R values. So, what can we pass here? Something that as a name does not work, because it's an L value. And something, and other L values like string littles also don't work. Oh, wait a minute. It works. A string little is an L value. Why does it compile? Yeah, there's a hidden operation. It creates a temporary. This is calling a constructor, creating a temporary string, and the temporary string is a PR value, and that's okay. So this is essentially the same as here. So it's easy. Otherwise, you have to use move. Good. Let's go to the implementation of this type, of this class, of this function, and look inside the class, because there's something interesting happens. S has a type and a value category. The type is, I am an R value reference to an STD string, but I have a name. And because I have a name, I'm an L value. And that means I can call myself. This does not compile. You have to place move again. This is, to some extent, the rule move semantics is not passed through. If you get something with move semantics, you have to say where to pass through the move semantics. And that's a good rule. That's not to torch you there, It's because we say, otherwise we couldn't use S twice in the function, because the first time it would lose its value. Good. But look scary behind the curtain. How is move implemented? A cast. A cast to what? To an R value reference. So what move does, it casts S back to its own type. Oh my God. And if you are at this point and you always thought, yeah, you have a type and then you have a cast to get another type. No, it's not that easy. Because the key question is not the type. The key question is the type and its value category. And with move semantics, we can no longer hide that. That has always been the case. If you had a traditional reference, so an L value reference, we had the same rule. Using it followed the rules of L values. And just for fun, we run into more trouble because you have to look very, very carefully what this type on the left of the 2 ampersand is. Is it a type really? Because if it's a type, it can only bind to R values, so you cannot pass an L value, whether it's non-const or const. But if it's and that means that you can be sure that S is never const. But if this is a template parameter, the rules change. Because this is what we call a universal reference. Oh, what we call universal reference. We didn't have a name for that. There was just a rule saying if we have an R value reference, we still say this is an R value reference, of a template parameter type, then different rules apply. And don't assume that this has anything to do with this. It's just that we in the language like to give the same syntax completely different meanings, just to confuse the Russians. Or whoever. I'm sorry. So this compiles. And that creates some interesting questions. For example, I first should tell, there was no name for that. Scott Myers invented the term universal reference here. Well, Scott Myers is not part of the standardization committee. So, another guy inventing good terms for us, is this a good idea? But you can't say that. Universal reference is a bit too universal. I think we have worse terms than that in the standard. But the decision was, no, that can't be called universal reference. We need a special name, but a different name for it, just to confuse the C++ community. So we have this named in the standard now, since C++ 17, a forwarding reference, which is the same name as universal reference, but just to confuse whoever. And as I said, S now can be const. So that's important. It's sometimes you want to know, can this be const or not? Because your code depends on that. And if that can be const, your code might behave differently, or you have to do something in addition. And now the question was, what is with this? So if my parameter is from a template parameter depending member. So does this follow the rule on top, or does this follow the rule on the bottom? Who knows? Who thinks this follows the rule on the top? Who thinks this follows the rule on the bottom? Okay. There were some frightening guys here who didn't raise their hands. It follows the rule on the top, of course. This is not a template parameter. This is a member of a template parameter. That's not a template parameter. The only reason we have this disaster is because this was the alternative discussed. And we have a big problem. You're all laughing. This looked so silly that people prefer torture over simplicity that looks weird. That's a thing you should learn. In the standard committee, we are cool guys. Cool guys are experts, and cool guys understand what they do, most of the time. Which might be not nightmare for application programmers, but who cares? Hey, they have to learn where to place, how to write a constructor. Psst. So we come into the interesting part of the 50 Shades. I talked yesterday with Karina, hi Karina, about this. And we had an interesting conversation, which I don't repeat completely. But roughly, the idea was, if it's so weird, if this committee is so weird, if this community is so weird, let's Google for C++ bondage. Do you know who knows what bondage is? You were right. Okay, being tightly coupled using towels and, no, probably something more interesting. Okay, so what happens if you Google for C++ bondage? So you find the experienced applications, practices of really sophisticated C++. This. Yes, they have this sign. That's bondage, yeah? It doesn't hurt that much, but it's only a sign. And they wear it. And they mean it. If they talk to you and they tell you, hey, maybe you should use a const int pointer, they want to have you write it const int pointer. How weird is that? Well, no, we declare functions like that. Return type on the left. Okay, so now you know what it really means if you ever meet somebody wearing this. I Googled a bit more, and I found even more weird guys. And that's like, by the way, just to confuse the rookies. This guy I found. And now there's the best story of this whole week. I will tell it for my life. Because I took this picture. I took it from Google and put it here in this talk. And yesterday evening, I was running here to the welcome reception and talked to some people over wine, and at 11:30 p.m., I found this wrist. But without the green and the yellow wrist, just the others, with a few more. I said, what? You know, I'm just preparing a slide and I have this picture I'm taking and that and that. Oh yeah, that was my wrist. I tweeted this picture. Timur, where are you? There. So he's a cool guy. That's a cool guy. That's not a tough guy. That's a real cool guy. Because they don't care. Because they are not following some principle that drive you crazy. Why are we discussing whether the const is on the left or on the right? Maybe you do it so that it is self-explanatory. Because if the const is in the middle, you always are wondering what it means. So place it on the left, if it applies to the int, and place it on the right, if it applies to the pointer. So it's time for me to show my wrists. Some people think this is too complicated. This is too much of a chaos. Okay. Good. So where are we? What's my time? Oh, my goodness. There's a third part of this book. It's called Freed. So let's talk about the third part. Who are the right people, or what is the right method, or what is the right way to solve us out of this mess? To help us with this mess. First of all, We want you, application programmers, for standardization. We have too much experts. They understand what they standardize, and that's a big problem. It is. Because nobody else. Nobody else does, including me. I'm not that smart. That's my biggest benefit. So I ask again and again and again and again. And sooner or later I understand it. But the more I understand, the more I get this interesting smile on my face with this some satisfaction after torture. So there's another thing maybe we should do. We should use style guides. We need style guides. Who writes style guides? So we need the ones to help us out. The ones who can tell you to put us on the right path. The problem is, as Jens just said, he passed away. Or what did you say? No. Yeah, so Scott Meyer's retired. Herb Satya is currently not writing books or blogs. We have nobody giving us style. So we have to find it all ourselves. And that's not easy. It was not even easy when Herb and Scott wrote style guides. I remember this interesting discussion here. The discussion was, if you have a unique pointer and you pass to a unique to a function a unique pointer, should you declare it with 2 ampersand or not? So Herb said no. And Scott said yes. Herb said no. Because if you don't declare it with 2 ampersand, it might not move. It doesn't move if it doesn't have 2 ampersands? Yes, these are the rules. Because the funny thing with move semantic is that it might happen if you pass something by value. No, it will happen if you pass something by value, and move semantic is supported, and you pass in something that is temporary, which both can only be the case in unique pointers. So although this is no claim to move, this is a guarantee to move. And the answer might be, if people call this sync and pass a unique pointer, they want to be sure that afterwards, whatever this unique pointer represented, owned, has passed away. It's no longer there. Which, by the way, is not the intention of move. Marking something move says, I'm no longer interested in this value, but there's no guarantee. So Scott's argument is, but here, to ampersand, I make clear that this has move semantics. And as usual with move semantics, the rules are, we claim that we possibly steal the value, but there's no guarantee to move. If I understood it correctly, after a couple of emails and discussions, Herb now more agrees to Scott's style. That's good. But we have other places where we have contradictions. So I come back to the way, how should we initialize objects? So we have the core guidelines, the CPP core guidelines, which some people now ask me, oh, is this the style guide of the C++ community? No, it's not. It's just one style guide, and it's not good maintained. It's not that when we prepare a paper and propose a new language feature, that we say, and by the way, we recommend that the following way the style guide should be rewritten. Remember, style needs time. So when we standardized templates, we didn't know which beast we created. When we standardized namespace, we didn't know which nightmares we created with ADL. And when we standardized move semantics, we didn't know what the new style is to write just even simple classes. So how should we know now how to initialize an object? Yeah, so the guidelines here are roughly the way I would give them. But if you look at another famous place for style guides, Upsale, they have another view on this. They say uniform initialization, direct initialization, has some problems. It's a stretch. It's not exactly intuitive. I always thought if it's one thing, then it's intuitive, but okay. It's especially something where people need change. So how much should we change our habits? It's interesting. Thinking about a new way to initialize objects, it's bad because I have to change the way I program. Yeah, we are frightened about style. But do it 3 months. I did this experiment. So, and they have a very easy other rule to teach. They say use assignment syntax when initializing directly, for example, in float and string, or smart pointers such as set pointer and unique pointer with containers when performing struct initialization or doing copy construction. Use the traditional constructor syntax with parentheses when performing some active local rather than don't use. You got it. I don't want to teach this to beginners. I don't want that. So don't get me wrong. I don't say always use brace initialization. I say I teach brace initialization as the default way now because it's the safest way of initializations we have and the most consistent and the most supported way of initialization. It has its flaws. And there's sometimes the need to do other ways of initialization. But that's our problem. Our style change. So Houston, we have a problem. We have a project, a software project that started 50 years ago, almost 50 years ago. We have 45 years of backward compatibility. And we are still constantly evolving. It's driven by the community of experts. And that's, to some extent, two problems. It's not a chief architect, and it's not application programmers, novices, or rookies, as we say in American football. So please take care. Please take care. Take care for style, take care for this language, and take care that the average programmer can still understand this language. Thank you very much. Hey, wait. How much time is left?
Half an hour.
Half an hour? Okay, I need 30 more seconds. It's important that we bring this out to the world. This message of this talk. So I decided that I want to create some merchandising stuff for this idea. Unfortunately, it was not finished in time. But in 1 or 2 weeks, you can order these things. You can order a combined wrist. And the most important thing, you can order the new Include t-shirt, which is this. Thank you very much. Any question? Any questions? Should we have questions or not? I don't know. Any questions left?
Questions? Questions?
Hello.
Hello.
First of all, a little anecdote. Some people don't say uniform initialization, they say unicorn initialization because it doesn't exist.
I think we're pretty close. We are pretty close. We fixed most of the problems, really most of the problems. There were 2 left, which we fixed in 20. Timur proposed one of them. I proposed the other. I think it's fine now. It's really fine now. We have no gaps left.
It will be fine then.
It will be fine then. No, it's good enough. I think it's good enough because the corner cases we fix are not what people usually do. Mm-hmm.
Okay, could you go to slide 19?
19. Oh my goodness, he found a bug.
It's not a bug. Unless you count performance bugs.
Of course, I'm C++ programmer.
The passing the set string by value in the set name, I think Herb Satya proposed this sometime after C++11 was done as a new default to pass by value. But Howard Hinnant, whom you surely know, he benchmarked it. He was very mean. And he found out that stat string, for instance, or stat vector of, or even stat vector of string, often the copy assignment beats the creating a new value and moving because you don't have to allocate memory in many cases.
And do we have the same problem in the constructor?
Not usually because you don't have memory in the constructor already.
So then we should both think about the way we teach that now.
Yeah, sure.
That's a problem.
Absolutely. Well, that's how I try to explain it.
No, you're right. There are counterexamples to this.
Yeah.
And it's not the point that I claim this is the right way to, always the right way. Mm-hmm. There's no always right. There are some multiple styles, and these styles sometimes have different benefits depending on different contexts. I agree with you totally. That's part of our problem.
Thank you very much.
Thank you.
Hi. I agree with you because I think C++ is on the verge of collapsing. Yeah, no. Each new feature is an attempt to fix the previous feature, and the language has been growing for pretty much 10 years now. Do you think we can fix the language without putting on the table the subject of backward compatibility? Because at some point, if we want to drop features to make things nicer and cleaner, we will have to break backward compatibility, in my opinion.
First of all, I don't think you're right that the most of the time we have new features that fix old features. I think it's more a problem that most of the time we introduce new features without fixing the old features. And that's not always an issue because we don't agree that something has to be fixed. It's just that fixing bugs is less fun than providing something new. I know that. I just try to pass through the beta std thread class. So the concurrency working group standardized thread, but they made a couple of mistakes, and the one serious mistake was that it's not an RAII type, one of our nice acronyms, which means that if you don't call join or detach before the destructor is called, you get terminate call dump. And I tried to fix that because nobody at the concurrency working group wanted to fix that. They just wanted to introduce, I don't know, semaphores or something like crazy things like that. Just kidding. Yeah, and I took the task. I have no clue about that. And it took me a lot of time and a lot of effort to fix that. And I now understood a lot more about that. But that's the biggest problem. The biggest problem is fixing things takes a huge amount of time and effort and understanding. And then we have to agree. I mean, think about this auto-initialization with the equal sign. That was a compromise, which I think was a nightmare, really a nightmare, because it simply means that we can't no longer teach to use the equal sign in initializations in generic code. So our problem is maybe that nobody is interested to do uncool stuff in the C++ committee. We are not paid. I can't complain at anybody. That's a problem.
Thank you.
Thank you.
Hi, just to mention, he said, why don't we break compatibility? So I counted the number of classes that were broken by C++ 17 because unary and binary function were removed, and it's 568 classes, some of which are not unit tested because legacy. And thank you.
Yeah, one thing about that. We try to be backward compatible, and there's a reason for it. The reason is not to get the nightmare of Python, because we now have 2 Pythons. We have Python 2 and Python 3. You see what happens if you break compatibility in a significant way. We break it a little bit, but it turned out that we have, even to keep binary compatibility. So, for example, we made the mistake that we didn't standardize the lockguard type as a variadic template. And so in C++ 17, we had to introduce a new type because just switching a template into a variadic template breaks binary compatibility. So it's a big issue because, and that's a good argument, if you compiled your code with old GCC or old Visual C++ 5 years ago and you want to link against your library against something else, it should still work. And that's one of the success stories of C++, but we pay the price for it. And the price is big, and it's getting bigger and bigger. So more and more we have to think about that, making it right that the first shot fits and does things right. Yes, we might think about stopping standardizing C++ anymore. But there are so many cool features.
So I have a question to that then. Like what you said before, wouldn't that be then a cool idea to introduce such like a bug fixing working group to advertise it like you get like cool wristbands or something? So you can spend your free time to fix bugs?
Do you want to be a chair?
Well, I'm not experienced enough, sorry.
No, that doesn't matter. You will become. That's good.
I take the job.
Okay. We have some thoughts about it. I mean, we are not blind. We see the problem. And, there is this story about Google that they really got completely chaos in their code base. It's one of the biggest code bases of C++. And if we want to try out, does it break any significant code, then one thing we do is we ask the Google guys, could you please change your compiler a little bit and then try out the new feature and see what breaks. The problem is, as always with Google, they only have experts. They take the best people from the market, and they don't have the problem the average programmer has. And in fact, they don't have the problems the average code base has. So again, as usual, if people say, but Google does it that way, 99% of the software is not like Google. So this is a problem. And we try to do our best to find out what it breaks. We try even to come up with some consequences and maybe some stories that over a couple of standards we fix things, but we still have to compile and link with code written in C. And in C++ 03. It's a problem, yeah.
Thanks for your talk. It was very nice. It reminds a little bit very famous talk on JavaScript, which is called VAT talk. But I like this one more because it's a little bit constructive. I mean, it tries to propose.
So you like my talk more than the most important Java talk you ever saw?
Yes.
Thank you. I buy you around.
Yes. But I have a question about one thing which wasn't mentioned here. Long time ago, for probably many of us, C++ was the language of choice because it was really nice to work with. And right now, it's probably life of everybody here. We write 3 set name functions usually. We write 3 get name functions usually. Those are different between each other with few characters only. Is it like movement, an idea? Is it be seen that it somehow makes C++ language no more so not nice to use, especially as you explained for rookies? Because the moment you see that you need to write, actually to make control, copy, control, paste 3 times, change few characters, and it's over and over again. Is there some idea, are there any ideas to fix this, to address this?
Don't forget that the biggest reason for the success story of C++ is performance.
Thank you.
Thank you. Don't forget that our biggest guideline is performance. And that's the way why people should program in C++. It's not because it's an easy language. If you need an easy language, use, I don't know, Ruby, Python, Java, or even D. Andre is not here, I can say that. And I like it. And him. No, don't forget that. That's our compelling argument. And there are good reasons people use that. And there is no free lunch. So you don't have to write all these getters. You can still write your code the way you could write it in 1998. But as performance is still an issue in our world, there is no free lunch. You have to do something to support that. And if you're interested in this performance, then this is a price. We could make things better, but I promise you, everybody of these 170 people tries hard to make the best. It's just that we have different opinions what the best is.
What I'd like to emphasize about the talk you gave is your last slide. The very last one, where you included rookies, because I think it's very important for the C++ community to remember that most of the programmers out there are not C++ programmers, probably could be C++ programmers, could benefit from C++, but regard it or disregard it without even thinking twice about it because it's not modern. And you hear this sort of thing over and over again. If you want to use something modern, it's going to sound like JavaScript or Python or something along those lines. And I think the hurdles that we have created into trying to get into it, which sometimes are colored by what we saw the talk earlier about theory and hypothesis and so on, and trying to change the way we talk about things and trying to treat programming more like a scientific application, to get us out of some of the religious warfare that goes on as to why you do something or not do something, which only confuses people and divides. And I think that trying to come with a more standardized engineering practice, as I remember, for example, with the C++ FAQ that used to be out, and that's sort of where I came in, is that, okay, every class you write the big 3, and then you're done. And things seems to have changed, and it's really hard to know how to orient yourself. It's so confusing. I'm just going to use Java or C# or whatever else. And I think we need to realize that it's very hard to teach C++. It's very hard for people to want to learn it, and it's very hard given that the public perception is generally, it's old-fashioned, it's not worth it. that we need as a somehow community to become a little more scientific about it?
Yes and no. I mean, yeah, I think we have too many experts. I agree with that. That's partially my role to represent others. You know, I try to come and still feel that I came over language wars. I still think, no, I don't have to convince anybody to use C++ at all. If they think they have something better, use it. What's the problem? It should just that I think that for my cases and my interests, it should be fine. I never understood why people think they have to sell their invention as a universal thing. I don't understand that. But because we use it, and we have some interests to use it, we should make it good. That's all. And then success will come from itself, and just maybe because competitions who use other languages are out of the market after 3 years, but maybe they are not, because the project succeeds, and the C++ project doesn't. But it depends on so many issues. No, let's just care for ourselves, eat our own dog food, and make things good. That's all.
Okay, I'll try to maybe clarify what I was trying to say is that no, I don't think there should only be one language out there.
Yeah,
I
got it. Yeah. No, that was not, yeah.
It perceived in a better light because I think it is a great language and not to be disregarded where it could be considered by newcomers.
Yeah, but for example, if you say, let's go scientific, that also worries people. It should be simple. Keep things simple. That's my point. And we should really hide the details so that nobody sees all the problems behind. We can do better, but we can't do the best way because of the problems we saw. Thank you. Jens, we are done, or you have a question?
Almost done. Any more questions? Come to the microphones. I have a simple question for you. I didn't read the books, and I saw your title. I thought, okay.
Which books? So that 50 Shades of Grey?
Yes. Did you read them? That's what I would like.
This is a fun story. I only was recently. I had a date, and I saw the film of the third book. It was interesting. I thought interesting. So why do you ask?
Because I didn't read the books, but I heard that some people who did read the books were a bit worried about your title, and
okay.
I trusted you with the title, and you, I think, gave a great keynote on C++.
Okay, let me say two things. The things that worried more than the title was the last slide, the T-shirt. Because I think Include CPP is a very, very important movement we have in this community. It's the same thing, but from the other way around. It's that we should be very careful how we treat those who are underrepresented in our community. Whether it's women, whether it's gays, whether it's whoever. Mm-hmm. And it's very important that we treat them well, and that we white guys, we have only one black guy in the standard committee. More women than black guys. Does it mean something? No. But that's a problem. We have a problem. And it's important to be empathic about it, so to care about that we make things right here. And so I was thinking about, is it lowering the idea of the T-shirts? And on the other hand, my opinion is care for the others. Care, especially in these times, care for the ones that are minorities. It's very important. That's what makes good democracy a really human democracy. And but part of caring is laughing. So we have to laugh. Don't stop to laugh. Don't take it too serious, because all these dictators in this world hate nothing more than laughter, because you lose control when you laugh. So care and laugh and have fun. That's all. And everything else comes from itself. And yes, I don't know about the details of this title, 50 Shades of Grey. I don't know about the value system. All I learned, each and everybody can have their own value system as long as they don't think it's the only truth. That's it.
Thank you.